Okay, so here we go with tonight's lesson. Have you ever had a number that was really, really, really big, or a number that was really, really, really small? Well, we don't like dealing with those numbers, let alone writing them out. So what we try to do is we use something called scientific notation. And you're thinking, science and math? Well, yeah, and then you could ask your science teacher about this as well. But what we say is that a number that is in scientific notation is a number that is written as a times 10 to the nth power, where 1 is less than or equal to a, which is less than 10, and n is an integer. Now, when I say 1 is less than or equal to a, which is less than 10, basically what that means is that a is a number between 1 and 10, but it can actually equal 1. That's what scientific notation is. So a number like 12,760,000, this number is in what we call standard form. It's not in scientific notation. A number like 0.00001276 is also in standard form. Those are standard form because they don't have the power of 10 associated with it. But if I was to write 1.276 times 10 to the 7th, or 1.276 times 10 to the negative 5th, this is what we call scientific notation. So the big question is, how do we convert between scientific notation and standard notation? If you think about a number in scientific notation, let's say 2 times 10 to the 3rd, and we want to put that into standard form. If you think about the long way we could do it, we could evaluate 10 to the 3rd, which would be 10 times 10 times 10, which we know to be 1,000. So this is 2 times 1,000, which of course simply is 2,000. But actually, that could make a really difficult thing if that had been something like 4.82 times 10 to the 15th. You don't want to have to deal with that. But when you look at this carefully, you may have noticed something. And what you may have noticed is that the decimal point on the 2, which was here, actually got moved over 3 times to give me the 2,000. So when we see a positive exponent, to go from scientific notation into standard form, we're going to move the decimal 3 places, or the number of places, to the right. Let me show you another example of that. Let's say I have 6.8 times 10 to the 5th. In this case, the 5 tells me to move the decimal place 5 places to the right, or 1, 2, 3, 4, 5, which in this case tells me that I have a 6, 8, and then notice that there's 1, 2, 3, 4 loops that don't have anything in it. So that would mean I add 4 zeros into those loops, and I get 680,000. What do you think I'm going to do if I have 3.25 times 10 to the negative fourth. So here I have a negative number. Yep, you got it. You're going to move the decimal 4 places to the left. 1, 2, 3, almost running out of room there, 4. So what I get is 0.000325. So let's kind of write this down. Scientific notation to standard form. The exponent tells you how many places to move the decimal point. Positive exponent means move to the right. Negative exponent means move to the left. Let me give you a couple to try here. Alright, so let me give you a few to try here. If I already said that, I apologize. I got interrupted, went to go delete something, and I accidentally deleted the slide with it on there. You didn't need to know all that anyways, but try these for me. 3 times 10 to the 5th, 4.395 times 10 to the 4th, and 6.79 times 10 to the negative 6th. Okay, pause the recording and see what you come up with. Okay, if you did this correctly, you would have come up with 300,000 for the first one, 43,950 for the second one, and 0.00000679. Now, be careful. The exponent does not tell you how many zeros are there. The first one it did, but look at the second one. Not even close. There's only 1 0. All it tells you is how many spaces to move that decimal point. Okay, let's say we want to go the other direction now. We want to go from standard form into scientific notation. So let's say, for instance, I had, well, let's take a simple one here. Start with 4 million. Now remember, in scientific notation, we want to get a number that is between 1 and 10. Well, if I say the decimal point is there, let's change that to a red decimal point. Is that a number between 1 and 10? I don't think so. So maybe we'll move the decimal point 1 space over there and make that, 400,000. No, that's not a number between 1 and 10. 40,000. Nope, that's not a number. 4,000. Nope. 400. No, still not. 40. Nope. 4. Aha. 4 is a number between 1 and 10 times 10 to the, well, the exponent is going to be how many times we made the decimal point jump, which in this case is 1, 2, 3, 4, 5, 6 spaces. So this is going to be 4 times 10 to the 6th, and it's a positive number because I went from a really, really big number to a small number. Look at this one now. Let's say I do 1,000 or 18,900. What do I do here? Well, look again. Here's the decimal. And if I move it over 1 space, I get 1,800. No. 2 spaces? No. 3? No. 4, there it is. 1.89 is between 1 and 10, times 10 to the 4th. Now you're probably asking, well, what if it's a very small number? Something like that. Well, we do the same thing. No, 1, 2 jumps, no, 3, no, 4, no, 5, no. There it is, 6. 3.6 is between, and that was 6 spaces. But it's not positive 6 because I went from a very, very small number. It's going to be negative 6. Let me give you a few to try and see how you do with this. Well, actually, before we do that, let's write down the rule that we want to do. So if we want to go from a really, really large number, or we want to go from standard notation to scientific notation, we're going to basically move the decimal until the number is between 1 and 10. But of course, remember, that doesn't include 10. It could include 1, but not including 10. Now, if we move to the left, we're going to have a positive exponent. If we move to the right, we will have a negative exponent. All right. Try these for me. And that one. And you know, let's try this one. And see what you do. Stop the recording and turn those into scientific notation. Okay, so the first one's pretty simple. We go 1, 2, 3, 4, 5, 6, and we get 3.61 times 10 to the 6th. This one we would have gone 1, 2, 3, 4, 5, 6, and we would have gone 5.82 times 10 to the negative 6th. Now you're probably looking at this last one going, but Mr. Cass, it's already in scientific notation. But it's not, because 36 is not a number between 1 and 10. So for a second, I just want to focus on 36. So we're just going to look at the 36 for a second. And if I want to turn 36 into scientific notation, when I move that back one space, and that would become 3.6 times 10 to the 1st. But don't forget, I already had that times 10 to the 3rd there. And because these have the same base, I can make this 3.6 times 10 to the 4th power. So I was able to turn something that didn't look like it was in scientific notation, or look like it, really into scientific notation. Now, the last thing we need to talk about is ordering of numbers in scientific notation. Because sometimes we're given a group of numbers and we want to know, are they in order from least to greatest? So, for example, let's take a look at the following. If I gave you 2.08 times 10 to the 8th and 4.38 times 10 to the 8th and 6.64 times 10 to the 7th and 2.45 times 10 to the 8th. And I said to you, put these in order from least to greatest. Now, obviously, they all have the same amount of decimal places. That's not an issue. But look at the exponents. The 8, let me show you here. The 8, the 7, and the 8. Well, because of that, obviously, the 7 is going to produce a fewer amount of decimal place moves, so that's actually going to end up being a smaller number. So the 6.64 times 10 to the 7th is going to be the smallest number. When I look at the other ones, which all have times 10 to the 8th, now I can look at the actual numbers, and what I find is that the 2.08 is the smallest of those, so that'll be times 10 to the 8th. And then the 2.45 is next, times 10 to the 8th. And then, of course, lastly, the 4.38 times 10 to the 8th will give me the largest of those numbers. So that's how I can order the numbers, by looking at the exponent first, and then by looking at the decimal number itself. All right, make sure you understand that, because you will have an assignment tomorrow in class. See you then.